Hi guys, let us deduct Coulomb's law from Gauss theorem. So we just learned about Gauss theorem. So the Gauss theorem says the flux phi, electric flux, I can write phi suffix c equal to closed integral of E bar dot ds bar, which is equal to charge enclosed q by epsilon naught. Charge enclosed by epsilon naught. So this is Gauss's theorem. And what is Coulomb's law? Coulomb's law, suppose if you have two charge, let us take positive charge, and here somewhere you kept a positive test charge q naught. Coulomb's law gives the force between them, F equal to 1 over 4 pi epsilon naught q naught by r square. So by using Gauss theorem, I need to prove that one, Coulomb's law. By using Gauss theorem, we need to prove Coulomb's law. To prove this, I consider a positive charge. So this is my positive charge. So in this positive charge, at a certain distance r, I consider a spherical Gaussian surface. A spherical Gaussian surface. Now here you can see the electric field line, which is coming from positive charge, is piercing the Gaussian surface. So here you can take area vector. So the area vector also along in the same direction. Now according to Gauss law, what shall we can write? The flux through a given surface, electric flux equal to the closed integral of E bar dot ds bar, which equal to charge enclosed q by epsilon naught, or charge enclosed by epsilon naught. Since here E bar is uniform electric field, means it is an isolated positive charge, in all the directions electric field lines are similar. So it is a symmetrical charge distribution, isolated charge. So it will be out of integration. So I can write that E bar out of integration times the surface integral of ds bar, which equal to q by epsilon naught. Now here we need to know what is the Gaussian surface. Now here you can see the surface is a spherical surface, spherical Gaussian surface. So I can get surface area of a Gaussian sphere. So that I can get in terms of the 4 pi r square, because here r is the radius of the Gaussian surface, which equal to q by epsilon naught. So from this equation you can write electric field E bar equal to, you can take this term to other side, it will be changes 1 over 4 pi r square q by epsilon naught. If you can rearrange the denominators, so I can rewrite the terms, which is equal to 1 over 4 pi epsilon naught q by r square. So this is the expression, we already know what is the electric field due to because of this point charge at a given point. From this electric field I need to write Coulomb's law. Coulomb's law means nothing but the force. For that we need to bring a positive test charge. For Coulomb's law, bring a positive test charge. Bring a test charge. For the convention, we are always taking a positive charge as a test charge. Suppose if you bring a positive test charge at here, so you know the what is the electric field at there, and you can write the expression for the force. And we know the relation between electric field and force and the distance between them. So I can write that since electric field E bar equal to force per test charge F naught by Q naught. So this is the relation between electric field, Coulomb force and test charge, which also you can write the force F bar equal to E bar times Q naught. Now you can substitute this value at here in the place of the electric field. So you can get the force expression. The force, Coulomb force F bar equal to, I can write that 1 over 4 pi epsilon naught Q by R square and times Q naught. So if you can write that in clear cut, F bar equal to 1 over 4 pi epsilon naught Q naught by R square. So this is nothing but Coulomb's force or Coulomb's law. So we derived Coulomb's law from Gauss theorem. So here I started by taking Gauss theorem. So we started by taking the Gauss theorem. So that electric flux equal to the closed integral of A bar dot B bar ds bar equal to charge enclosed by epsilon naught. So that is the Gauss theorem statement, and we ended up with the Coulomb's law. So this is the relation between the proof of Coulomb's law from Gauss theorem.